Well, time to end the stream. I just got one of the CD robots delivered. Like, it's now at home, apparently. So, okay. I was going to say it's going to be delivered today, but it was delivered today, literally between me getting up from my chair over there and walking over here. I had just checked it. Anyway, hello. So today we are doing more work on the Python software ripping nonsense stuff, because there's going to be a CD thing tomorrow to work with, and we're really close to being like fully ready to utilize that and start implementing it. So I would like to try and finish up a couple more things with it before we get started with that whole side of it. So, yeah. I think that's it. I feel like there was something else, but hopefully not. Let me just really quick test something here. I didn't have the ability to check this before stream.
TikTok is now online.
Okay. That is working. All right. Yeah, I think we should just get started. Okay. Boom. Let's just make some progress here. Okay. See Robin melting in the sun. Yeah, no kidding. Okay. So, first off, for giggles this morning, if you watch the mail video, you will have seen me get the Micron Millennia manual here. All right. Well, this is now on archive.org. You can go look at that in all of its millennia-ness, and check that out. So I just ran this through the ADF, but I also ripped all of the media that came with it, and I used the new fancy pants web interface for this. So the software is not currently running, or is it running? It's not currently running, or is it currently running? It is currently running. So let's take a look at what we've got now. So this is the ripping interface. It's mostly the same as it was last time you saw. Actually, it might be completely the same. I'm not sure. I don't remember what I last saw. So there's that. And now we have this, a status page that you can look at. So in this, we get outputs for every media sample it has ripped. So let me just give you an idea. Under output here, I have ripped 4 things. I know how to count. And each one of these was either a CD or a floppy. So These two here were CDs, so they're ISO 9660s here, and there's files extracted from them. I did get that working. And then the other two were floppy disks, so they'll have flux. So the software is putting together a table that can be displayed in a web interface, so you can see, you know, oh, this one was this, it was this media type, I ripped it with this drive. I started it here, although this is only on this media type because I added this in the middle of this process because I realized that this was like a good idea. And then our files that we outputted under the bin and queue process, we got a bin, a queue, and a talk file. Here are the files. I'm going to make it so that you can click these and just like download it directly from the Pi or whatever you're using from this, just to like view it in the web browser. I think that'll make sense. And that'll be really easy. We'll get to how in a second. So it goes through all of the files that are output from the RIP and displays it all here. So that was a CD. Here's a floppy. The floppy gets a flux view, and we can actually view this image in a tab to see what the flux looks like if we want. HXC is called dynamically to generate this file, and it gets saved into the status here because it's not really like data output, so I'm putting it under status for right now. It tells us what our data outputs are. I had, up until a couple of days ago, not been actually tracking what raw files we output. The order of these are real wonky because I'm gathering these with a Python glob. So under, actually it is floppy here. After it rips everything, it goes and globs all of the files in the output directory, and it apparently doesn't care what order they're in, and I haven't bothered sorting it yet. So that's what we're getting. But this outputs like 160 things if it's an 80 track floppy. So yeah, I know, sorted. I just like, literally this wasn't a problem until this morning. So I didn't even see this until just like now. So this will output like 160 things. So I put a limit of 20 on it for now. Because the other thing is that if you run this on, say, an audio CD, it'll show the flax.
At tier 1. They've subscribed for 38 months, currently on a 37-month streak. End of line.
Moonwire, thank you for the tier 1 sub and for 38 months. I appreciate that so much. Thank you. If you're ripping flax, they'll have the track names, and you'll probably want to see all of those. So I limited it to 20 of these because I figured if it's any more than that, you probably don't want to see it anyway, because you'll get a rough idea. So if there's more than 20, it just stuffs an ellipsis on the end and calls it there. So yeah, I think that kind of gets you up to date. Now, unfortunately, these are still two separate pages. I would like to make them one page, but that's a problem we'll get to later. The problem I was trying to work on this morning that I couldn't solve yet, because Python's weird apparently, was trying to figure out how to handle static members of a class, and I couldn't get that to work. So we could work on that. But I think what we should do instead is work on making, I haven't figured out how to like conceptualize this, drive buses, it can't be drive groups because that's how you handle ripping in a group here. So that's a little different. But for example, and I kind of had this almost be an issue one time when I was demonstrating this. So let's say you have a grease weasel, all right? It is connected to 2 drives. You can only access 1 drive at a time. So those 2 drives are tied to the one grease weasel interface. In this software right now, there's no way to link the 2 grease weasel drives to one interface, so the software does not know to not try to rip multiple drives from a grease weasel. This matters because once I get the plunk chunk, you know, ARM-based CD robot, I have to be able to tell it, hey, these 3 drives are all controlled by this one ARM. So if one drive is like done and so is another one, don't try and remove both disks. One drive has to go through, it's like, oh, it's a whole thing. So there needs to be something that tells it to wait somehow when handling stuff. And I need to figure that out because it's a little weird. So I think we should work on that today because that will benefit the disk ripping. Now the CD ripper thing that used your optical drive for the first time in years. That sounds right for most normal people. So let's figure out. So let's think about this. How do we want to handle this? So currently we have
CHEER 100. You need a queue for it. Otherwise, it will be as impatient as Chat. End of line.
Chloe, thank you for the 100 bits. There is a queue in Media Reader here. It is media samples as defined right there. I would like to expose that object over the web interface as a JSON, but so far I have not been capable of doing that. And I don't know why, but that's a problem I'm not going to try and solve right now. I need to figure out a way of assigning these maybe to interfaces or something. I'm not sure. Paul Guy, that kind of makes sense. They like doing that. Yeah, they like sending files that way. Okay, so let's think about this. Well, that's a little more complicated, Von Trez. There's going to be a dedicated class file, essentially, for the CD robots, no matter what. Both kinds are going to be different. So each one is going to get its own class defined, which is going to be annoying. Maybe we just define, I don't know, a grease weasel? I'm not... Well, that's easier said than done, Von Trez. Is the way it has to work within the current structure of the software. So, transit biker, no. Let's see. Let me think about this. So let me go through how this works currently. So we have Media Reader, and when we're ripping groups here, we get a list of files that are what'd you call it? They're media samples, okay? Media samples check for drive groups in this crazy way here. Every time it goes through all of the media samples, the first thing it does is it checks if the media sample is done somewhere around here.
Willie, please
Here it is.
Tier 1. They've subscribed for 31 months and says almost hit 6 bits PECHPA 5 NYANWIN 1 PECHPA 5 NYANWIN 2 PECHPA 5 NYANWIN 3 End of line.
Willie Fleet, thank you for the tier 1 sub in for 31 months. You are limiting, or at the end of 5 bits for sure there. But thank you. Okay, so let's talk about this. We go through all of the groups for drives. So a group would be a drive type, a drive that is capable of reading this kind of media. So a 3.5-inch drive can read these. A 5.25-inch drive could read, 5.25-inch, and a CD drive could read this. So that's what drive groups are, because if you have multiple drives in the system, this will handle using multiple drives for handling this stuff. So there's that. So the way this works, it looks to see if the drive has a process attached to it and whether or not it is active. So if the process is active, it won't continue. All right. That's only if it's the first run or something. That doesn't matter. Or no, that's for saving the drive state for other stuff. Okay. If the drive is not active, it goes through media samples and it finds a media sample that has not been finished. So if it's done, it just skips and keeps going. Okay. So if the media sample does not have the group set, then hold on. Yeah, okay. If the media sample is not in that group, then it continues on to look for another media sample that is. When the media sample passes because it hasn't been ripped and it is in that group, then it is assigned to that drive that we're checking a process for, and then it sets up a process that gets assigned to that drive, and then it executes that process and starts ripping. Okay. So, all right. Here's how I think I want to do it. I have an idea. We make a new class that, let me think about this. Who's still blinking? Yeah, I'm just trying to think it through. I think we have an orchestrator object. Yeah, the arm state, that's a little complicated. I don't think I want to do that. So I think we implement an orchestrator, and we assign the orchestrator to samples as they are run, and then the state can be retrieved from the orchestrator. So no, let me put it this way, Vontrez. So let's say you have your A 3.5-inch drive and your B 5.25-inch drive. Okay, so the limitation is the grease weasel interface, it being preoccupied or not. Okay, so in this case, the orchestrator would just say, well, let's say you're ripping drive A. It tells you to put something in drive B. You are told put something in drive B, so you do that, and then you click a button that says media loaded. Okay, the software, this is not implemented, but it's going to have a button that clicks to continue. Okay, there is already a load function in this. So it is somewhere in here, load media type. All right. This has to finish executing before it can continue. For CDs, the way that works is it waits until like the tray is closed by the monkey pushing the button. Okay. In the robot version, it will just say, I've finished loading the disk into the tray and closing the tray. Then it will automatically release and continue. Okay. So for the grease weasel, okay, let's say there's two drives. All right. There is an A drive and a B drive. Okay. You load a disk and start a rip in drive A. The grease weasel is then preoccupied. Okay. But let's say you also have a rip defined for drive B. It can tell you while drive A is ripping, load drive B, okay? But it can hold on this, on the load type. It can stay locked there and it will never start the rip, which would collide with the other grease weasel. So you'll load this and then it'll wait, all right? You can click the button that says media inserted, begin or whatever, but then it will continue to hold it until the grease weasel is free. As soon as drive A releases, then it can start reading drive B and it will tell you to remove the media from drive A. So it shouldn't not associate a media sample with a drive just because that drive group isn't available, at least for the grease weasel. So it should go ahead and do that. The CD ripping robot could handle that in different ways by also, well, we'll get to that when we get to that. But for the grease weasel, at least, that's how that should work. So we need an orchestrator that is assigned to all drives connected to a grease weasel that says, hey, this drive is currently reading, so wait during the load process. Yeah. So I think that's what we need to do. So let's think about how we can do that. So we need for the grease weasel, for the floppies, we need a parameter that we can set that says, hey, these drives are connected to the same grease weasel. So under the settings here, there could be a group, but there also needs to be an interface. Or how do we interface? How do we want to handle this? I think the logic is going to be similar for the grease weasel and the robot. So I'm going to just do the grease weasel right now, and then we'll adapt that logic to the robot later when we get to it. For the record, the robot that we're going to have access to tomorrow, not going to need this. It's much dumber. That one, let me just show you. What is it? Like, I don't even remember what it's called. Hold on. Robo Racer LS. So I'm pretty sure it is the single drive version here. So yeah, it's just a spindle and it just spits one into the drive, does whatever it does in there, and then spits it out to the side. So yeah, it's one at a time. That's what the one we are gonna have access to tomorrow is gonna be. So drive queuing and all that stuff, not relevant to that one. The other one is the auto publisher LS. And yeah, that one gonna need orchestration. So that one, it will matter. That one's gonna be super complicated, but we'll get to that later. That one's gonna be really bad. I don't know what this spindle's for. Yeah, I have no idea what that spindle's for. Anyway, I'll have the manuals and stuff. So, yeah, tomorrow we won't be working at this. So, you know what? Let's call this controller. Controller. Okay. Maybe controller ID, actually. The Hanoi bot, yes, absolutely. Because it's going to be that. If I load up 200 disks into it, it's going to have to deplete one stack into the empty, column, and then it's going to have to deplete the other stack into what was a filled column. So yeah, the logic for that is going to be fun. I also don't know how to control it, so that will also be interesting. I am very much not sure how that's going to go. I also don't know what the the plug interface is. Because there's nothing. I'm afraid it's FireWire. USB 2.0, okay. Ouch. We might be hacking it up and installing a Raspberry Pi inside to directly control the drives because, yeah, USB 2.0 drives are gonna be rough. But we'll see. We'll see how that goes. No clue. Okay. Controller ID, let's say GW1. All right. And we'll put this one on GW1 as well. I don't have a B drive connected to this thing right now. Let me just do that real quick. Pretty sure that's the brand new drive. Yeah, that is. That definitely is. Okay. Plenty fast for CD reading for 3 drives.
Goose says PHDER 100 honey. Have you seen my B drive? End of line.
Probably. I don't think so, but we'll find out. We're gonna be hacking away on it a lot because it's actually a CD duplicator, not a ripper. So I'm gonna be doing all sorts of stuff to it. Okay. Let me grab some kind of media to test with here. So, first off, yep, drives work. Let's just real quick, GW clean drive B. What? Drive A. GW reset.
Subscribe.
Okay, that worked.
They've subscribed for 31 months, currently on the 31-month streak, and says 5 flat bits in a row. End of line.
Well, that didn't work. Okay. Chloe, thank you for the 100 bits. And Schmide, thank you for the tier 1 sub for 31 months. I appreciate that. All right. CDs are slow? No, they're really not. If I took the Plex stores out of that karaoke duplicator, you would be surprised at how fast they can be. Okay, why is this not working? Oh, because power came unplugged. Cool. You know what? I'm gonna go get a power extension and plug it into that, because these have the, like, the pinch things that are used to try and eject the connector, and they're getting stuck on the drive. There we go, that'll work. Okay, powering, drive B. There we go, better. All right, for grins and giggles here, I've never actually ripped a 5 1/4 inch disc with a software, so let me just try that really quick. I have a really dumb floppy that...
In your area today, CHDER 100. End of line.
H. Vontress is referencing the heat wave that Arizona is currently going through, or Phoenix area. Okay, so we're gonna rip drive B, media name, oh, you know what, actually, hold on, I don't want to rip where I am. That's the Micron folder. Archive. Well, let's do it here. Archive. Test. Okay. Refresh. Okay. Group. Drive B. Test. Floppy. test floppy. Let's pretend this is an IBM 360 disk, because I don't actually know what it is. All right, so it should start ripping in a second. No. PyCDIO. Why? Well, that's different. Can I get file status, non-group rip?
GOGOGADGEP
Wait a minute.
360 subscribed at tier 1. They've subscribed for 21 months.
That was my fault.
And said, well, that's different indeed. End of line.
In case I didn't say it, H. Fontress, thank you for the 100 bits. And GoGo Gadget, thank you for the tier 1 sub there and for 20... So my software's getting 21, but the back end says 24. I was actually checking it today. I don't know. So thank you for the 24 months that my software apparently doesn't show. Like, I resubscribed. Like, I don't get it. Like, this is 31, that's a streak. So, like, not calling you out or anything. My guess is that you resubscribe for the first time after not having subscribed for a while. That's my best guess. Weird. I don't know. All right. Let's try this one more time and actually set it as a floppy disk. Okay, go. Aha! Ripping. I don't know where it's getting this information. Run. Okay, Dogface, blah, blah, Belkin. Okay, so the software currently does not output anything for the status until it has finished the initial rip because it's weird. So it's going to read through this first. Then we'll get a output here. And then after it decodes it to binary, it will decode the flux to an image as well. So currently, we would end up in the race condition if I attempted to also start a rip on drive A. So that's the problem that we need to solve right now. So we will test that. I mean, I know it'll fail. Right now, it will just straight up fail. That's what we're going to try and fix. We should also implement the web control for restarting drives, but that's a different problem. It might be time to implement SQLite. I'm not sure. You know what's funny is this disk said it was formatted. I don't know what it was formatted as. We're about to have an idea, though, because it's about to have a flux image. So we'll see. Found 18 sectors total, only the first track. Well, this will be interesting. Takes a while for HXE to generate the image. Especially if the tracks are all not formatted. Okay, should be done. Oh, look at that. Oh, woo. Oh. Oh. Um. Let's add a feature to the floppy software. Um, so, one of the options you have for GW read is it's not, that's not that. Where seek number, no. No, it's not. Is it here? Step. Oh, it is here. Okay, so we can do this. Number of steps between cylinders. Okay, so I need to set the flux output here for tracks step equal 2. No. This is an 80 track drive and I did not double step. That's the problem. Test floppy 2.
Tier 1. They've subscribed for 41 months. And says, seeing how you familiarized yourself with all the CT formats, PCO is next on the menu, right? Alright. End of line.
They already exist. SCSI's the best way to do it, and the Mac SD, as far as I'm aware, is currently the best option for that. Okay, so let's try this again with step equal 2. You forgot IDE? Yeah, no, if you're going to want IDE, that's on you. Personally, I don't see a reason that you should bother with an ODE. Because everything supports SCSI. There is literally no system that doesn't support SCSI in PC land. At least that you should bother with. Or is reasonable to try. Also, IDE feels like it would be a lot easier, but that's a different thing. So SCSI's more impressive. Okay. Curious how this goes this time. Okay, I screwed it up again. All right. Good try, everyone. Good try. Okay, next attempt. This time, we put a colon here. C equal 0 through 39. Huh? What do you think about that? I know how to rip a floppy. Yeah. No, okay. In all fairness, I don't normally use an 80 track drive for this, so I did actually forget. Chloe, isn't it just as difficult to load drivers for an IDE drive? Like, I don't see why SCSI would be any worse. Do copy that floppy, yeah. I've done a lot of copying this morning already, getting the Micron stuff going. It was a nice test. I wish I came with a 5¼ inch disc, so I actually had to try this before. Okay. So now we'll have floppy 2. It successfully decoded it, so that's good. Next, it's going to make the image. The image should go a lot smoother this time. There it is. Look at that. That's looking a lot better. We're not using the default config or the built-in config file, so it's not going to attempt to extract the data. So I did notice this is an option now. You can just mount a floppy image. I have no idea what's on this disk, so I'm not showing it to you. I don't have any idea what that is, but I'm not showing it to you. But yeah, so that does work. Okay. I don't know why you need... H. Vontrez, Hellencroft here designed a card for that, so that's entirely possible. I have the card in this computer right now. LS PCI. SCSI. Grep. Boom. PCIe to PCI is easy though. How many like fancy pants HD 68 CD drives that are SCSI do you think you're gonna find? I think you're okay with a PCI bridged chip. Anyway, okay, so there's 5¼ working. That's all doing good now. Okay. So back to this. We need controller IDs. Okay. So so how do I want to handle this? So I think we're going to have to make a controller group, which, ugh. Handler. So let's make folder controller, and then I forget which one of these is the simplest. Is it just this? Actually, optical is definitely the simplest. We'll start with that. Okay, GW. Okay, so media, or no, controller GW. I don't know if I want this to be derived from handler. I don't think there's a whole lot of reason to. So we'll just start with object for now. Is it lowercase? Okay, it's lowercase. Just meant in case there are any PCI. Oh yeah, if you have a PCI slot, yeah, SCSI is super easy. Okay. So we're going to have an ID string. We're going to associate drives with an ID. So there's a problem I haven't actually handled here. Maybe we properly account for this. Maybe we do this. Let's see, GW read, and then drive default A. Okay, but isn't there GW H? I mean, info. Can't we somehow specify a specific grease weasel to use if you have multiple of them connected? Isn't that a thing? Let me try this. I've never connected two of them. Yeah. So, second grease weasel that totally didn't fall behind my desk. This is being plugged in for the first time. Hopefully it doesn't explode. Okay, good, it didn't. So now... what? Now? Why does it not see that one? Let's unplug the other one. Replug. LS, USB. Does Grease Weasel work? Let's try this. Sudo dmessage. Okay, PCIe bus error correct. Oh gosh, stupid nonsense. Okay, so USB that's static-ish. Plug in. Why is this not working? Oh, okay. Weird. Maybe the cable wasn't plugged in all the way. Bleh. All right, so now we plug in both grease weasels. Boom, they're both there. Okay, now GW info. So that's 4.1. The other was 4. So if I unplug that one, 4. Yeah, okay. Okay. Stupid wireless USB, yeah. Culminated, I would just try Kubuntu. That would be my recommendation. I think it would run fine. It'll give you a real desktop and it'll just work. There's a reason I run Kubuntu on literally all of my computers that are modern and do real work. Including my old Surface that I use for basically the same thing that you're using it for. Mine's maybe more powerful. I don't know what old-ish i3 is, because that one's oldish i7, I think. There was some reason I didn't go straight Debian. I looked into it. There was something dumb about it. I don't remember what it was. Okay, -D device. Is that the same for all of these? Read. Device. Okay. COM or serial port. Okay, so we have to specify the serial port to utilize the other one. So it's AMC 0 or 1. That's right. It's the movie theater. So info, device, that. Okay. I had Ubuntu Netbook edition going on a netbook back in the day. I might have swapped it out for just 1204 because it was that, dude. I am genuinely nostalgic for Ubuntu 1204. Like, that's actually a thing. It was good. It was so good. Okay, how do we... Oh, gosh. I have not let myself think about how I would handle multiple grease weasels yet. Actually, I think multiple grease weasels is solved very easily. You just set it in the config. I did not expose that here, but I think I need to. Because it is kind of a unique feature for it. It is going to matter for the, what you call it, CD robot, but I think literally no one ever is going to have a CD robot or multiple CD robots connected to one computer. I don't see that happening. It says the guy who's about to own 2 CD robots. But they're different. And one of them's going to stay at home. Yeah, okay, so let's do this. Device, that's what the option's called. Yeah, device, okay. So we're just going to add... it's going to copy this. Device. That. And then we go up here. And then we just add... I'm going to do it under PLL device. None. Boom. Okay. Now, the cool thing about the software... All right. Let's go back really quick. There is no device option there, but as soon as I refresh, it's now down here because that's the flux. That's the flux decode convert out. Wait, did I put this in flux? Not. Oh, I put it in flux. Not. Well, you got the idea. It is incredibly easy to add configurable options to this by just doing that, but do it the right way, not the wrong way like I just did. I put that under PLL, right? No. There we go. So close, rerun, refresh. Okay, device under flux output for floppy. Okay. Now supports multiple CD robots. Yeah, really. Yeah, Sleepy Developer like that. I am about to own, I guess I looked at it in this window. I'm about to own one of these. So that's in the mail, but then this is on my doorstep right now. I need to go home and grab it. So tomorrow we're going to play with this, which is going to be really simple to implement. Hopefully, knocks on particle board with laminate on it. Yeah. No, I don't. PJB, I don't think so, because this is different, like, completely. So. All right, so now that solves the grease weasel thing. I'm not going to worry about that anymore. I think that that's good enough for that. Don't know how I'm going to handle it for the CD robot. There might be a configuration option there. For the record, eventually, when you pick your media type, it will filter out the config options based on that. I just haven't bothered with that yet. That is planned. So, like the CD options will only show when you have it set to CD or auto. Yeah. But for right now, they're just all there. So I should probably add a, well, let's look at the grease weasel coordinator again. Let's go back to that. So we solved the drive problem, okay? We don't have to handle that. Oh. No, that's fine. We don't need to worry about that. I was going to say I need to be able to set the drive in the coordinator, but we set the control ID. That's going to be our way of handling that. Yeah, that's the thing. Yes, okay. Okay. How do we want to handle this? Or how? Okay. So let's say in Media Reader, all right, it's going to go rip a thing. I'm trying to decide where it should be. So there are two methods that you can use for ripping. Drive, a Q drive rip like this uses a CSV, and then it just rips from the CSV. It doesn't watch for a web interface at all. It doesn't even support that. It just goes linearly through the CSV in the exact order you specify. But it still supports drives and checks if a drive is in use, but it doesn't support drive groups. That's a whole different thing. Drive, and that would impact Grease Weasel. So Grease Weasel would still be affected here. Then there's the drive queue groups, or the RIP queue groups. This uses the, JSON files that are generated by the web interface or manually if you want. I mean, I actually do that kind of a lot, because when you rip these, the status file here is identical to these, except it has a bunch of extra garbage. So if you just copy this out and then remove the done true flag, you can use that to re-rip. So what I'm thinking, let's say always controllers are used. So it would be in this rip here. How does this work? Q drives. Does this use rip auto? It does not. This is threaded. Well, PJB, what I'm getting at is it would be possible to connect multiple CD ripping robots to one computer, but they are very expensive and complicated, and sticking one Raspberry Pi in each one of them or something along those lines nowadays really wouldn't be a big problem and would let them run independently of each other, and I feel like that is the much more sane thing. So only supporting one of those really doesn't feel like that big of a problem, because that's what I'm going to do. I'm just going to stuff a Raspberry Pi in it and control it that way. I'm going to have to do that no matter what, because it's not designed for reading. It's just designed for disk duplication. I don't know if it has... I'm not exactly sure how it works. So I have a disk duplicator over there where you load a disk in one tray and then in another, and then it reads and copies directly like that. I don't know if that's going to be how this one works. I don't think so. I think it's going to be you have the ISO on a computer or whatever, and then it just burns it to 3 drives at once and then automatically changes them out. But I don't know how it's going to work. So there's going to be a lot of trial and error tomorrow, or when we get the actual CD Ripper robot. I suspect that single one is going to be really easy. There's just going to be a kick button and a drop, kick command and a drop command. That'll be really easy. So I don't think that'll be a problem. So I'm wondering if maybe the media handlers, so let's say the floppy handler here, okay, should have a controller check or something. Maybe it should be in the load process. I'm just trying to figure out where to put the check for the controller and then how we access the controller data. So if we do it, yeah, like I said, we would do it in load before. So let's say under floppy for the load. Why don't I have a load function here? Am I just using a default? Probably. I'm probably using that. Okay, so let's say we implement a controller function into this. What would this look like? So under load, all right, the floppy handler could import controller. How many L's are in thing? You know what? Let's just control. I know how to spell controller. Media handler. Okay, why is it all handler? No, it is handler controller GW. That's it. Handler GW and then controller. Okay. And then we would import controller GW. Okay, so let's say we do this. Under load, we could run controller GW or while controller GW wait ID. And then like time, sleep, 5 or whatever. You have to go, Dutch Black Cat, no problem. See you later. Hopefully it's all going okay. Okay, so under load, we wait for the controller for an ID, and it would actually be media sample controller ID. Okay, so how would controller handle this? So we would have def, wait, and here's the other thing. Should the controllers be instantiated? We can have multiple grease weasels, so it feels like they should maybe. But how do we handle that? I'm afraid that it's time to implement a database. So, PJB, here is the problem. Everything is threads. I think so Drive A is currently running, and it has told controller somewhere else to be blocked. And Drive B is also talking to controller, and it's querying if it is blocked. But these are all three separate threads. I think we have to implement a database. I think it's time. Oh no. I can't think of a way of doing it without doing that now. Uh-oh. No, it's going to be SQLite. Hopefully SQLite in memory, but I don't know if that works the way I think it will. We might have to be an SQLite file in the temp folder. Bad me just wants to have it be a JSON file, and we just read that. And that is that how it should be? I don't know how. That's all for today. No. It really isn't a problem. It's been a while, but I'm no stranger to SQL, so it's not an issue. What does this look like? C library provides lightweight disk-based database. It doesn't require a separate server. Process allows accessing database using non-standard variant of SQL query language. ATM teller machine. Some applications use SQLite for internal data storage. It's also possible to prototype an application using SQLite and then port the code to a larger database such as Postgres, SQL, or Oracle. Where's MariaDB? Come on. They do that all the time. Maybe it's been a while since I've worked in SQL, but I don't... SQLite 3 module was written by that guy. Provides SQL interface compliant with DB API 2.0 specification provided by some peppers. Requires SQLite. Wait. What do you mean it requires that? It's not like all in Python. Where's the robot? On my front porch. Yeah, so this is specifically what I need to be able to determine. If I can connect and disconnect, that's good. But we could run into concurrency issues still. I assume there's a disconnect. I mean, I know it's going to globally lock the file. That's like the whole problem, though. So, like, here's what I'm saying, okay? We're in this situation. Drive A is ripping. Drive B is waiting to rip. Drive B is occasionally querying the database to see if it's free or not, okay? Drive A finishes, but it happens to finish on the exact tick or whatever that drive B also queries to see if the thing is free. And that means that drive A had the database connection open when drive B also tried to access it. If I have a static class that is used to interface with the database, drive B's would crash when it tries to access the database file. I could have a try except and then just loop if it does it, if it fails. I think that's lame, though, but maybe. I can't have I don't think I can. Can I pass a connection to the database as an object? To a process? It's easy. Easyac, literally no one ever said it's easy when it comes to threaded concurrency problems. No one. What do you mean, yep, but only writes lock to DB? You meant the lame option. JSON files? JSON files still kind of run into the concurrency problem, though. It doesn't really solve that. The retry loop. Oh, yeah. I mean, I'm tempted. What does the lock file need to contain? So, the drives, all right, are going to have a name specified to the drive. So drive A on this system is a 3.5-inch floppy drive. So floppy A would be maybe floppy A dash 3.5 inch. All right, so there's a name. Okay, that's not getting saved. Drive A is passed as a parameter to the Greaseweasel software to say, hey, rip with this drive. Group is something that is used internally by my code to handle what order to rip stuff in. Let's just pretend that doesn't exist. Type says it's a floppy. That's pretty self-explanatory. And then we have controller ID. Okay. So what we need to store in the lock file is basically a tuple that says this controller ID, so in this case, GW1 equals A. Then what will happen when drive A finishes ripping, it can set this to none, let's say, okay? It can null it. Drive B can check periodically and see if this is null or none, and if it is, then it can go on and associate its drive with this. So now GW would be B, and then we can continue. So basically we're storing a tuple for this. Isn't that just a unique file name, as it's analog to the real hardware? So what you're saying is we could just write a file GW1 and put A or B in it. Node.js, I handle such things using database, set of flags, X is running, timers that check if X is not running. So you're saying you would track the processes, essentially, to see if they are still going. So I have that kind of, but I'm not using it for this, and it's a little hacky. I don't know that I want to make it a dependency. So there is a process state checker thing here, and that is used to determine if a process is finished, and if that drive is free. So let's think about, so for the grease weasel, we would take the controller ID. The only thing I think we would ever do with it is just wait for all other drives to be done ripping. And in most cases, like 90% of the time, like I'd say 99.9% of the time, it's just going to alternate. So that one's super simple. As a matter of fact, table in the DB is named state, yeah. GW callback. Sounds like you're writing an operating system. It almost feels like it at times. So I guess let's say a lock file could make sense. Maybe we don't open the file. Maybe we simply check for the existence of the file. So drive A starts a rip, creates a lock file for its controller ID. Drive B is given information, checks if there is a lock file, it sees the lock file, and then it waits. Okay? Drive A finishes, it deletes its lock file. Drive B checks, sees there is no lock file, recreates the lock file, and continues. Manual resolution, if it exists, is very difficult. But what it could be is it's going to be in the temp folder, and I could just purge the temp folder on startup because there's nothing in there that should ever be kept. We already purged the input folder, so maybe we just purge the temp folder on startup That is a good point. I'm trying to think if there's any problems with that. It could be a problem that, let's say you are the weirdo using 3 drives on your Grease Weasel. So you might get into a situation where one drive is always being locked out or something like that. It won't necessarily always go in the order that you want. How would this work with preserve order as well? That's kind of a nightmare. I think it would be fine. I'm glad I'm not solving. Yeah, really. Okay, so let's think about how this works with the CD robot as well. So the CD robot will have a controller. Well, Super Scott, I'm thinking the lock file doesn't even need to contain anything. Its existence alone could be enough information. So drive A is currently ripping. When drive A finishes ripping, it will delete the lock file. That is the only time the lock file would ever change, is the process that is using the Grease Weasel will delete the lock file after. Drive B will be waiting to check if there is no lock file. If there is no lock file, it creates it, and then it, will delete it after it's done. The file's not truly locked. It could be deleted by any process. Just the existence of the file means, like, hey, don't do anything. So, okay, let's think about how this works for the robot. So the robot needs a lock file that says, hey, my arm is currently moving. I'm doing something, okay? And then there's another thing in this when, for auto rip, where is it? Rip auto, okay. So if wait is not done, it waits until all preceding processes that have already been supplied. This is where process state matters. It waits for all preceding processes to die, so to finish. So each one of these would lock the robot, unload their media, okay, and then eject media would be where the robot lock is called. Okay, so this would not impact this, and it should be fine. Okay, so software interlocks, be careful, don't shoot yourself 10 times. Yeah, I know, right? Also, I saw you message me. I did not have a chance to read that. Sorry. Just plan for happy path. If not, about worry things die. I'm not sure what you mean there. See, the robot doesn't block queue commands. More specifically, I need the software to control the blocking and queuing of commands so that I know exactly which disks are in which drive and in which order. So here's the thing. The big robot can hold 200 disks. So I have a stack, let's say, of 200 disks that I rip. It's probably never going to happen because I don't think I want to sit here and type 200 at once. Let's say I load in 200, okay? I take all of the jewel cases for every audio CD or game or whatever. I open it, put the disc in there, and then put the jewel case over here. I grab the next new jewel case, open it, put the disc in, put the jewel case over there. There is an order that the discs go into the robot and that the jewel cases get stacked. And I need to make sure I maintain that order, or else it will get to a point where some games, which are smaller, maybe the ones that don't use CD audio, will rip faster, and it will upset the order that they are ripped in and then restacked in the robot, which would make it impossible for me to take the stack out, flip it, and then go draw disc case and then rejoin them all super easily. So this is already making sure that the order that the media is ripped is preserved. So it cannot change. It's not allowed. That would be horrible. Use blank jewel cases. I'm not making new discs. I'm ripping existing ones that come in their jewel cases already. I mean, yeah, your thing is just put the discs in paper sleeves after you're done, and then just put that back in the box. The changer can't put things back where they came from. This is the changer. All right, I wasn't kidding when I've been making the Tower of Hanoi references. Okay, so here's how this works. You load up the thing back here. Load up the thing back here, all right? It takes one disk out of here, puts it in one drive. It rips it, and then it puts it in this bay. Yeah, not a carousel, no. No. So yeah, so they'll end up reverse stacked for one, but these just pop off and then you just put it down there. It's not a problem. But you need to make sure the order stays the same. Okay, so here's the things that I think the CD robot needs to know. The CD robot needs to know what drive it's putting the disk into. You can't auto eject on complete then. No, but that's already handled. That's right here. So this tracks which drives already have ongoing processes and waits for those to die, because when it starts a rip, there are any active processes, those need to be finished first. So that's already handled. That code works perfectly. I've tested it very robustly. But what needs to happen is the CD robot needs to track when it has depleted a stack, and it needs to track which bucket it puts stuff into. So we can hold 300 disks total, but we can't, we actually have to shuffle 200 disks in there. You have to do the whole eject move as an atomic operation. Yes, that is one solid thing. So the way that it's going to work is it will run eject media type here. The CD will have a controller associated with it, okay? So something like this, all right? I might need a controller type as well. Floppy is just always going to be Grease Weasel. You're insane if you're trying to rip floppies using this with like a native floppy controller. I'm not even going to support that. Like straight up, I will tell people no. If you want to implement SuperCard Pro or, the actual HXC, what is it, Juliet or whatever, that's fine. I don't care about that. You go for it. That's fine. I will reject any PRs for native floppy controllers. But what was I going on about? Oh yeah, eject and robot and something. Okay, it will have for the CD here, okay, for this, an optical drive, will have a controller ID and a controller type, probably. So we'll set the type to, what was it? Auto Publisher LS, and then it will check for a controller that matches that. Associate that controller with the media sample. Somehow, I'll figure that out later. And then the CD handler would have something similar to what the floppy is implementing here. During the eject or the load, it will know load disk. Well, it's gonna. Oh my gosh, this is brutal. Well, so AI, what I'm saying is the order is already preserved in the software. The controller just needs to count. So let's say the controller counts internally that it has ripped 100 disks. It then knows that that stack is empty. Do you only care about the order because of the cases? Yes. It's the output order that matters for the cases. The input order is fixed. That's on the monkey that types in the stuff. The cases is the only reason. Because they could get very out of sync. When you're ripping with 3 drives like this is exactly the one I have on the way. If you're ripping with 3 drives, it could get pretty bad. I'm fairly confident that the time saved and having it maintain the output order will be better than the time loss from like trying to figure out which disk goes to which case. Someone decided to hang up. The whole process is failing to read for 3 days. Yeah. I have definitely encountered that kind of thing. So, okay, it will send a command. It'll have to send a command, eject this drive. But the controller will have to maintain the knowledge of where to put that disk, I think. That's the only sensible way. The software, yeah, okay. So the controller won't have any idea about the order. The software will always eject them in the correct order. It already does this. So this just needs to keep track of how many disks are in here. If there's, say, more than 100, then it knows that after it fills this, it'll shift to this. So the controller will need to internally track that, but outside of that, I don't think it matters. So we only, for this, the only thing we need to do is tell it which drive to pull the media from, I think. I actually don't know, because I don't know what the commands are for this. I'm hoping maybe it says it in the manual. Probably not. We're going to have to wire shark it or something. I don't know. Only full sets on completion. I'm not sure what you mean. Oh, AI, it's not, it's fancier than that. The way that my software works is way fancier. No, that's not how it works. So load A, load B, load C, yes, okay? Then B finishes, okay? It waits for A to finish, okay? Once A finishes, all right, the robot pulls out A, does that, whatever. It may then go, I'm not 100% sure exactly how this will work. It may go grab a new disk now and then pop it in and then start ripping in A, while C is definitely still ripping. So A and C can be ripping at the same time. It might then, after, notice that B is done, pull out B, and then go grab a new disk for B. So now our current order is C, A, B. The only thing that matters is that C at that point has nothing that it needs to wait for. A has to wait for C to be eject, and then B has to wait for C and A. So it keeps track of it like that. At all times, a drive will have a disk, and if the disks that came before it are done, then it will be able to rip. It works. You gotta trust me, it works. It sounds insane. You're upgrading to a ring buffer. It's already implemented. I'm telling you, that works. Is that just keeping track of when a drive started ripping? No, because let's say you have an audio CD. That's almost always 700 megabytes. But now let's say you have the driver disk that I have for the Belkin Nostromos N55. This CD right here is like 16 megabytes of data. The whole bin queue, or 60 megabytes. It's nothing. So this CD will always rip faster than almost every other CD ever made. So the order matters. You have to keep track of that. But what I'm saying is I think the only thing the robot needs to keep track of is which stacks it's operating on. I don't know what this thing is. So what I'm saying is I think each 3 CDs are a set of ABC, each set. I mean, I'm telling you, this is already implemented. We don't need to worry about the precedence. It's done. Here, you know what? Screw it. Let's just run the test. Let's just do it. Is it this? Open with Kate. Is this the one that defines it? No. Okay, you know what? Let's just do this really quick, okay? Kill this. Archive. Dummy. Test. Okay. Here we go. Running this here, okay? Oh my gosh. Stupid software with the unfinished things. Okay. Is this imported anywhere? I don't think it is, but let's just do return. I don't think I want self, but we'll get to that problem later. Okay, was it floppy? Floppy. Where controller ID. What are you complaining about? Line 163. 163, okay. Hold on, just, there, fixed. Okay. Run. Okay. Now, here's what I'm going to do. Okay? We are going to start ripping dummy objects. Okay? These have a random delay of up to 30 seconds. All right? The software is configured with 3 dummy drives. Okay? Each time it attempts to rip a dummy object, it's a 20-second random delay, okay? The order these start in is always going to change because of this delay. Then the amount of data that it's going to just DD from dev random is also going to be different. So these are going to vary wildly in how long they take to complete. Okay, so here's what we're gonna do. We're gonna start dummy 1, and then we're not gonna change the description, it's just gonna be dummy. Okay, I am going to start ripping 9 of these, okay? And you'll see how this works. So, dummy 1, start, go back. Dummy 2, start, go back. Dummy 3, start, go back. So you'll see it's loading these into their drives. Dummy 4, 3 finished, and it's waiting for this, or 2 finished, and it's waiting for another process. Go back. Dummy 5, start, go back. Dummy 6, start, go back. Dummy 7, it'd be really nice if Flask didn't also output to here, but yeah. So you'll see, as the ones that finish quicker are done, they have to wait for their predecessor. So 5 here was waiting for 4 here before it could start. After 4 was done, then 5 was allowed to finish. Dummy 9, start. Now, the output order, 1, 2, 3, 4, or no, 5, then 4, then 6, then 7, so that is not maintained. Say the very first disk in the stack has a nasty read error. Even if the next 2 disks finish ripping, they'll be blocked behind the first one. Yes, correct, as it should be. So there it is. Now it finished. So that's how it works. When one finishes, but there are predecessors, it waits for the predecessors to finish before it itself then finishes. So the order is maintained. Now the start order doesn't matter. It's a fine first cut. Yeah, I don't know, a ring buffer. Is it phi? First in, first out. Circular buffer. I mean, kinda, I guess. Doesn't feel like how that's how I implemented, but yeah. I still don't like they have to manually enter data. Well, guess what? It's never going to be solved. Did you, out of curiosity, did you not get my year 0 reference? Maybe you never had the year 0 CD. Year 0 CD. You got it? Okay. For those of you who don't know, what DZAC is recommending I do is use like image recognition to try and fill in all the data automatically. So year zero is an example of a CD that has thermal reactivity. When you first put the disk in, this is all you see. When you take the disk out after it gets warm, this is what you see. So it changes. Now the album is listed on there, but the artist is not. So, yeah. Ring buffer is always FIFO. Okay. Well, it's not worth talking about that more right now. But okay. All right. Oh, there's our dummy objects in the output because it's totally random, I guess. I have no idea why. But cool to see that working. This automatically refreshes too. Okay. It's a fun edge case, yeah, and exactly why I wouldn't rely on that kind of thing. But then again, there's also all sorts of other things. Like there's plenty of CDs. What is it? Pink Floyd metal CD. Images. Oh, which one is it? What am I thinking of? I'm not gonna remember. There's one that's just like yellow, blue, and magenta, like clouds, where there's literally no text on it at all. I don't remember what CD it is, but their CDs are not guaranteed to actually have any kind of useful information on them. REM New Adventures in Hi-Fi? I mean, maybe. Is it just silver? Use Google Vision on stuff on your phone, see if it can find it. I guarantee you, in 5 minutes, I could go grab one. I mean, if we're going to do that, I could just use the Lord Clear CD too as like another example. So yeah, there's lots of them that are like that. Is there no hope to starting a career in software engineering without an internship? Dude, I don't know how to get into software jobs. Don't ask me. You want to know how I got a real software job? I applied for one through Craigslist, okay? That was to do Arduino development, got brought in, interviewed, was rejected, but then someone else in the same company was like, actually, maybe he could do web development. I went and I interviewed for that, knocked it out of the park, and then ended up being brought into the Arduino job anyway, once I finally got in there. So no, I can't tell you anything on how to do that. It's a nightmare. Okay, but bringing the story back. For the controller for Grease Weasel, pretty sure we can just wait for the controller ID. That should be possible. We just make a file in the temp folder for the Grease Weasel controller. We name it the controller ID. If that controller ID exists, we return true. Okay. If it doesn't exist, we return false, and that allows it to continue. This would then, start controller ID, maybe lock. Maybe that would be the thing. We run GW controller lock that, all right, which would then make the thing, and then under eject, where's optical? All right, under eject here, we would unlock after this, which would just delete the file. So that should work as our interface. All right. Except that I also need, oh, I was using the defaults, not that. So like that. That seems reasonable. Yeah, I think that would work. I think that's all we need for this. And then for the CD robot, we're going to have to do something stupider, but we can make it work. So PJP, the lock unlock is just going to be the existence of the file. There's not going to be any data in there. We can, if I can do a touch, like an OS touch in Python, I'm going to do that. Is your backend monolithic and directly connected to all the ripping hardware? Because otherwise, in the lock creation, you need to make sure you don't get two that read no file and then create the lock one over the other. This is where I think I was saying I'm going to pretend that it's not a problem. Matter of fact, let's just do this really quick. Sleep for 1 second, because that would solve the problem of it being able to load something immediately after. Anyway, here's what I was saying. On the Grease Weasel, only crazy people are going to run 3 drives. Okay? It should be 2 drives in like 99.9% of cases. So there'll always be one locked and one unlocked. Okay? You're not a crazy person. How do you even run the 3rd drive in a Grease Weasel? How do you do that? Like, you have to use Shugart addressing, don't you? Like, so you would need to make an adapter.
100 and all the other cases are Shelby.
End of line.
Yeah. That's, yes. Chloe, thank you for the 100 bits. But yeah, here's what I'm saying. For the Grease Weasel, there will be one drive that is holding the lock and one drive that is watching the lock. The other drive will release the lock. This one will see it. It'll engage the lock, and then the other one will be waiting. And it's fine if you have 2 Grease Weasels connected? Yes, because you, the monkey who configures it, should specify GW2 for any drives connected to the second Grease Weasel. So what I'm saying is drive A on this Grease Weasel 1 would be that. We could purely A-B toggling, exactly. So we could have floppy 1A, 1B, 2A, 2B, and then we have GW here and here. Now, yeah, not dual ripping on one. Yes, that's impossible. Now, the downside to this, okay, if I save this, run it here, all right, you can only specify your actual drive here. So the device, you know, dev, TTY, ACM 0 has to go there in your config. So that kind of sucks. But I don't think I want to change it, but I'm not sure. This is a problem that I think I could fix later if I really want to, but I don't know that I do. So we'll just not mess with that for now. I'm also really concerned, and part of the reason why I want it to be in this instead of the settings file is because I could see the serial IDs changing. And that we'll probably have a button in here for the Grease Weasels to run the clean command on them. For one, just because that would be a good idea to be able to clean the drives. So what I'm envisioning here, I haven't actually, it's like a self-code review with chat standing in for Rubber Duck. It really, really is. Yes. Oh my gosh. We have blown 2 hours and done nothing. Although we did come up with an architecture. So it's not all that bad. I know how it's going to work now. So there's at least that. What was I saying? Oh yeah. Envisioning, all right, in the future. So there's this window that shows you what all the stuff is doing, all right? I want these to be laid out like that on one HTML page. Prove Google Vision can ID a disk that's silver with little text around the hub. Okay. I'm telling you, there are a lot of CDs. There are enough CDs that just have zero text. Dartboard or playing cards is an achievement. So anyway, here's what I want. I want this over here on the right, the configuration input options on the left, and then what I'm thinking is maybe something that kind of looks a little bit like this program here does, where there's buttons and they're changing colors. So like a drive that's currently ripping something might have an orange button right here that's saying, you know, like in progress or whatever. Then red would be like maybe hung up or something, and then green would be like ready to go. But for the floppies, if they aren't doing anything, you need to be able to click that drive, and then that will run clean on it. When they're red, the floppies are red, that means that you need to go over and eject the disk and pull it out and change it. So that's, you will have to click the floppy drives twice. It'll be kind of annoying because you will need to click it to say I did eject it, and then you'll have to click it again to say I did load it, because there's no way of reliably checking whether or not a floppy has been loaded or not. So there's going to be something like that. So this is the layout I'm envisioning. So why was I talking about this? I don't know. And the monkey presses the button. Yes, that is a critical part because of floppies. The CDs can be fully automated, but floppies cannot. I'll do for ripping solutions. Yeah. You proved it can do it with no text. What do you... Oh. Trying to just identify the CD? I mean, that's cool. It's not happening. Don't care. Does not matter. How well do you think that's going to work on computer games? The Grease Weasel doesn't have a mechanism to check for the drive being closed. Not all drives close. I mean, that's not how it works. There's like not a switch in there that says disk is closed and loaded. So, all right, let me get rid of these extra floppy drives because they're going to drive me nuts. Do I want to put them in that? Should the device for the Grease Weasel be specified there? I'm starting to feel like maybe it should be. PJB, it's not exposed to the Grease Weasel. That's what I'm telling you. There's no way for me to know that I'm aware of. Yeah. I don't know. Maybe there's the weird pin commands. Pin, but it's changed the setting of a user modifiable pin. If we could read the pin state for... I mean, there's the disk change pulse. That's, I think, how it works, is it's a pulse. There's no way to do it that I'm aware of. And I'm not tying this software to some kind of like user modification where we like put a sensor or something in the driver trying to read that. Yeah, it's have the button. User says disk removed, Disk installed. That's about it. Changes when a disk is ejected. Yeah. Or inserted, I believe. Do we put the device there? So I'm trying to think about this list. How do I get the drive? I guess the drive state's handled separately. Yeah, I don't need it there. We don't need it there. We need it here. we need it here. It's not optional. We have to have it. But the good news is that we get to implement it without adding another variable. So the way I need to adjust this. Maybe I'll do this afternoon or before stream tomorrow. We need dev ACM 0 as a prefix to the drive letter. Because if we have two grease weasels and we're just using drive A and drive B, that's a problem. We can't do that. So yeah, I have to do this. Okay. That's a thing. It can assume if this doesn't exist, don't put it in. So if there's no colon or something like that. But yeah, I need this so that drives are unique. That's a config file. It can be. This is the default settings that are built into the program, and they're pretty sane, so I just use that. Like, you know, single drive is SR0, A is a 3.5 inch, B is a 5.25 inch, and then there's the dummy stuff. But you can export this as a config file, modify it externally, and then reload it as a parameter. So yes, it is a config file. Backend knows all the stuff is configured for with the device list become a drop-down or auto-select media based on what drive you pick or vice versa. So you get these JSONs here like this, okay? These define media samples. So Belkin N52 can be ripped with drive 0 and is type CD. You take this file and you just drop it into input. Boom. The software, it can't read it because the stuff's broken right now, but it will attempt, assuming that you put the CD in the drive, it will then rip it as that. This web front end just creates these JSON files. So you input these here in the order that you want to rip and then keep your media here. It saves the data that it reads from these in memory, and then we'll process them in order that they're created. So the actual details of the rip are stored in the JSON for how to read it. You can also put more complicated stuff in here. These configuration options can also go in there. So if we go Nextcloud, System Sync, this, Archive, Micron. For example, this floppy, which contains the boot CD stuff, or the CD boot shim for a floppy disk. So this file here contains everything about that, but then it also contains all of the configuration data that was set in the web page, and then it contains the settings. These can also be loaded in the JSON file. You know what, maybe not. I should add that. And then it contains the actual data output by the software tracked in there as well. So these JSON files rule the roost in this. Getting seem to be those are very to drop down so that device can be auto-filled. You pick a CD. Okay, hold on. You pick a type. So you pick CD. It could limit that to the drives that can handle CD. Yes, but then you will need to pick a CD drive. So if you have multiple CD drives, you would say CD. But here's the other thing. The config files don't specify types for drives. But yes, that could be done. That's a last 10% optimization. That's the same reason that you can set this to floppy here, and then it still shows the CDR DAO driver. Like this could be hidden as well. There's many minor things that could be fixed. I'm not worried about that yet. The server should know what CD drives it has. It will know based on the settings file that you provide. So you have to configure the settings file, which is a JSON file, for how that is set up. Okay, now let me real quick here unbreak all of this. What did that complain about when I tried to rip it? Raw media type to upper media type. What was wrong with the media type? GUIs never cause extra expectations? Yes. Yeah, again, that's why I'm not adding a GUI to the scan processing software. That's like literally exactly why. Because I don't want expectations. All right, let me commit all the code here really quick. I think it was going to be broken, so don't use this commit. Git add GW. Git add GW. Git diff. Let me make sure there's nothing stupid. Type optical controller robo. You know what? I don't want that in there. Okay. Type floppy, comma, GW1. Yes, I do want that. Okay, under floppy, I'm importing controller GW. I have added the device. For now, I'll leave that. I will remove that later. And then I added the eject and load. These are unimplemented. Let me just comment those out so this actually works. So let me just do this and that. And then that will be safe. Okay, git commit -am start controller dev for bus devices. Git push origin web. Boom. Okay, well, I gotta end the stream because I need to go home and play with a CD robot and hopefully find out that it's like a super duper simple serial interface that it exposes where you just like tell it put disk in and then it puts the disk in and then it's like the easiest thing to use ever, so I don't have to like learn how to use Wireshark, and that's the first time I've ever been able to double click with the touchscreen. That was crazy. And yeah, here's hoping that it just goes smoothly. So we'll see tomorrow. Hopefully it's not me going, oh gosh, this is going to be a nightmare. I regret everything. So we'll see. But that is it for today. So you just joined, sorry, but you can catch us tomorrow, 20 hours from now. We'll be starting at 10 a.m. Arizona time. I don't know what it is for people who do daylight savings. That's not my problem. You can look at the schedule down below on Twitch to be able to see what time it is relative to you. But hey, put the disc, left disc, but yeah, I catch, yeah. But all right. If you enjoyed this stream, you'll want to follow to be notified when I go live again next tomorrow, like I was just saying, because we're going to be doing cooler stuff tomorrow, relevant to what we were just working on. If you want to help support the channel, you can find me on Patreon or get a shirt like this one. But that's it for now, and I will see you all next time. And I am not anywhere near to the correct thing for printer. There it is. Boop, boop, ba-doop, boop. Come on, go. Go printer. Come on, do it. I got it.